Okay, question 12 is so much easier than question 11, and it will be on your test. There will be one just like this on your test. Okay, but the idea is the exact same as question 11. So they want us to find the equation of the polynomial, and they tell you two of the roots, but really by telling us two, they are actually telling us four, because if the square root of 5 is a root, then negative square root of 5 is a root. And if 5i is a root, then negative 5i is a root. And remember, if they tell us the roots, they're telling us the factors in disguise. So you just change the sign and you'll have an x plus, well, I'll do this first one here, x minus root 5 and an x plus root 5. And we said those aren't too hard to multiply. And these are so much easier to multiply than the last ones, the x minus 5i and an x plus 5i. Those are so much better than the ones where you had to put the minus in the parentheses. We're still going to multiply the conjugate pairs together. So we're going to do these two together and then these two together. So we'll take the x times x, which is x squared, and look, plus root 5x minus root 5x. So they do cancel. And then you have minus, remember, square root of 5 times square root of 5 is the square root of 25, which is 5, or the square root of 5 squared, however you want to think it, but just x squared minus 5. That's not bad at all. And look how about this one? X times x is x squared plus 5ix minus 5ix. And now I have a negative 5i times a positive 5i. That's negative 25i squared. But we know that's actually x squared plus 25 because I squared is negative 1. So when you multiply that, that'll be positive 25. And now you just have to multiply this to get your answer. X squared times x squared is x to the fourth plus 25x squared. Here's a minus 5x squared. There's the minus 5x squared. And then negative 5 times positive 25 is negative 125. And you get x to the fourth plus 20x squared minus 125. And that's your answer. So much easier than the last one, you definitely can do, and it will be on the test. So make sure you pay attention and understand that one. If you're having a difficult time, please let me know. Okay, question 13. I like this one too. Now, this is asking you for the zeros. It doesn't say rational because the one thing I really need you guys to remember is that rational zeros can be found with calculator. They can either be found on the table or they can be found by doing second calculate zero. Okay, so what they're doing here is they're telling us one of the zeros. They're telling you negative 2 is definitely a zero. And I could verify that if I wanted to by typing it into my calculator. And they want to see if we can find the others. Now, how many are we looking for? Well, we're looking for 3. I know 1, so there's 2 more out there. So if you want, you could type it into your calculator. So y equals x to the third, remember what mine was, plus 2x squared minus 6x. That was convenient. And minus 12. Now, sometimes you really have to look for them, though. Sometimes it's hard to see what's going on here. I'm going to go ahead and look at the graph first and see mine's all messed up because I was searching earlier. So let's go to Zoom 6, which is what we normally look at. And let's look what we see here. I definitely see 1. This guy looks like it's in between 2 and 3, so that's not negative 1. Is that what it said? Negative 1? Negative 2. There. There's the negative 2. So it looks like that is going above there, and I could verify that if I needed to. If I go over here and zoom in, yeah, you could see it goes up. So this looks like an in-between guy. Now, I could do second calculate 0, but it looks like there's a possibility it's going to be a decimal. So maybe they're square roots. So if that's the case and I do the second calculate 0, I could be wasting my time. So let's see what other options I have here. Well, since negative 2 is a 0, I can put it in the box and I could divide it out. And what this will allow me to do, put the coefficients here, 1, 2, negative 6, negative 12. Well, it will allow me to verify that it is a 0 because I'm going to get a remainder of 0. But it's going to make me turn this x cubed into an x squared. And I'm going to like that because I'm going to show you why. So let's have our party. We multiply, we add, we multiply, we add, we multiply, and we add. There's that remainder 0. I knew that was going to happen. Number x squared. So I'm getting x squared minus 6. And what that means is if I take x squared minus 6 times that factor x plus 2, which would give me the 0 of negative 2, that is equal to this guy, x cubed plus 2x squared minus 6x minus 12. That's equal to that. Well, if that is my function, it's in factored form now. Negative 2 is one of the zeros. The other two zeros come from this. So if you solve x squared minus 6, you can see what those other zeros are. You add 6 to both sides, square root both sides, and the other zeros are plus or minus the square root of 6. So my calculator would have just given me nasty decimals. So what is the lesson here then? Let me type it in. Here's what my lesson is. If they tell you a 0 and they ask you for the other zeros, yes, you can look at your calculator. And that's what 4-3 was about. If your calculator shows them nice and neat, then maybe they're irrational and you can use them. But maybe they're not, and you're gonna have to do it by hand. So this is kind of this is something you should always do in case it was easy, but it probably is not going to be easy. So then what you're going to do is you're going to synthetically divide, and then you're going to solve the quadratic that's left. Okay, because that's the way you can find the imaginary zeros or the irrational ones. So let's try another one. Okay, what about, oh, this one I'm actually having you skip. You actually are going to skip question 14 because you're going to have to do long division on that one, and I decided I did not want you to do that. So we're going to skip 14. Okay, so here's 15. They tell me that 2 is a 0, and they want us to find the other one. So again, I can look at my calculator and see if they're nice. But this time I'm not even going to do that because let's say I don't even want to waste time. So I'm going to put the 2 in the box. And I'm going to divide out 1, negative 10, 36, and negative 40. I know the remainder is going to be 0. The reason I know that is because it is a 0. They're already telling me that. So you have your party, you multiply, you add, you multiply, you add, you multiply, you add. There's the remainder I said. Number x squared. So I get x squared minus 8x plus 20. Remember, what is that coming from? It's coming from that times the one with the factor that comes from the 0, the x minus 2, equals what I originally started with. So this one is interesting because you might think this was factorable, but if you make your list for 20, 1 and 20, they have to have the same sign. 2 and 10, 4 and 5. None of them get me to the negative 8. So I would have to solve that by hand to get my leftovers. So your choices for doing that would be you could complete the square, but a lot of you do quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative b is positive 8 plus or minus the square root. B squared is always positive. That's 64 minus 4. A times c is 20 all over 2a, which is 2. So that's 8 plus or minus the square root of 64 minus 80. That's negative 16, which is nice, all over 2. And that's 8 plus or minus 4i over 2. So you love math, and you get 4, that's from the 8 over 2, plus or minus 2i. So the other zeros you could not have found with your calculator. You would have had to do it by hand. And I'm glad I didn't waste time plugging it in. 4 plus or minus 2i. Okay? Now, that's the only other one, I guess, of that I want to do. We're going to talk about here the possible zeros. Okay? This is the p's and the q's. Remember, you put plus or minus. There has to be a plus or minus the p over q. The p's come from the guys at the end, the q's from the beginning. So you're thinking of the factors of 15. So that's 1 and 15, 2 and nothing, 3, 5, and 15. And the factors of Q are 1 and 22, 2 and 11, 3, nothing, 4, 9, no, 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 no. So I guess 2, 11, and 22. So it's all the combination. So it's 1, 1 half, 1/11th, and it looks like they started at the 15. So do you guys see that? So 15, 15 over 22, but it has to have the plus or minus. So it's the one with the C choice, okay? So those are pretty easy. Once you know the rules, you will want to look that back over before you take your test so you don't forget, okay? Question 18 is like putting it all together. Like what if you didn't have a calculator? What would we be doing here? But we're going to use our calculator too. So first things first, they want us to list the possible zeros, just like we talked about. P's are here, Q's are here. So it's plus or minus P over Q. And the P's will be 1 and 20, 2 and 10, 4, 5, 10, and 20. The Q's just 1, so that's pretty easy. Plus or minus them all. So 1, 2, 4, 5, 10, and 20. So these are the only possible rational zeros. And then they actually graph it for me. That's convenient. And they said, this is your graph. Which ones can you get rid of? Now be very careful when you decide what to get rid of. The reason I say that is because your graph does not always give you the full picture, because sometimes the scale is messed up. Now this one is okay because you see how it's x to the third and I actually physically see 3 of them. But what if it was x to like the fifth and I only see 3? You can't get rid of anything because look, 20 is not even in the screen here. So you couldn't get rid of 20 if it's not in the screen. But in this case, I will be able to get rid of 20 because I see all 3 of the ones I'm looking for. So I see all 3 of them, and definitely 20 is not even in the window, so I can get rid of 20. How about 10? Can I get rid of 10? Yeah, I can get rid of 10 because 10 is over here too, and I can already see 3 of them. So I'm going to be able to get rid of 10 and 20. And now they actually want to know what those rational zeros are. Well, it looks like maybe it's 2, and it looks like maybe it's -2, and it looks like maybe it's 1, 2, 3, 4, 5. Now, how could I tell for sure? You could synthetically divide, or you can type it into your calculator and actually look at the table and see if you're right. Now, I'm typing it into my calculator that's in front of my face right now since you're kind of already looking at a graph. So I encourage you to do the same. Plus, I'm faster at typing it in this way. Um, and I'm going to go to my table, and it looks like the actual answers are -2, like I thought, 2, like I thought, and 5. So -2, 2, and 5. I could have got them all from my calculator because they all did work out nicely. Sometimes it's worth typing it in to see. Um, like this one would have worked out nicely that way. But sometimes when you only find one, you're going to have to do it by hand anyway. So it's kind of a risk. It's sometimes worth taking. So now just fill out the factors, put them in the rest of the way. So that last one will have to be an x minus 5. Oops. You just change the sign on all those factors. Okay. This one, they're asking for the rational zeros. Okay. So, and then the other ones. So if they're irrational zeros, they would show up on the calculator. So you can type this into your calculator, take a look, second calculate 0 if it looks like it's an in-betweener, and then divide out like I taught. So I'd like you to try 19 on your own as well as 20. Does not mean you won't have questions on these. 21, the same thing. Those are the ones that are possible you don't finish. I want you to at least try to see if you can find the rational zeros. But those you might still have questions on. Okay, the process is the same. So this guy, the rule of signs, this is another thing that you're going to want to definitely make sure that you look back over before the test because it's not hard. but kids forget it. So you're just counting the sign changes, and that will tell you the possible number of positive roots. And then you got to remember that they could be imaginary. So you have to start subtracting 2 at a time until you get to 0 or -1. So let's see what happens here. Positive to negative, that's a sign change, just 1. Negative, positive, that's 2. Positive, negative, that's 3. So there are 3 possible positive numbers because it went 1 change, 2 change, 3 change. Now you have to subtract 2 because they could have been imaginary. So there's possible that there's only 1. So 3 or 1. You don't subtract again because then you would be in negatives and that doesn't make sense. Now, how about to do the negatives? The negatives is the one that's trickier because you actually have to do f of negative x and then count the sign changes. So this will be 2 to the negative x to the 5th minus 4 times negative x squared plus negative x minus 5. So there's an odd number of negatives, so that's negative 2x to the 5th. This will be positive, but there's a negative there, so that's a negative 4x squared minus x minus 5. So there's no sign changes here, none at all. It is negative the whole way across. So since there's no sign changes, there's no way there will be any negative real zeros. Okay? And you'll do these problems the same way. 24, I think it might be the rest of the way, guys. 25, 26, and 27 is a graphing one. Okay, so that's it. The only ones maybe that you won't have done are a couple of those trickier ones, but I do want you to at least try. And then you could ask questions. Don't forget to get a 50% on that review.